It's getting recorded, right? Am I audible?
Yes.
Oh, sure. So first question is like pyramid transistor matrix. We are stacking the blocks to form a pyramid, and each of the block will has a color which is one letter string, and we are allowed to place any color block C on the top of two adjacent blocks of color A and B. Only if ABC is an allowed tuple. So we start with the bottom row of the bottom, which is represented as a single string, and we'll start with a list of allowed triples, and each of the allowed triple will be represented as a string of length three, and we are supposed to return true if we can build the pyramid all the way to the top, else false. So here if we look, these are bottom BCD, then this can be from BGC if you see, and that is present in our allowed array, so it's possible. Then again CED is also possible, I mean combination of this. Next you can say AG or GEA, that is also there. So all the entire pyramid is possible in this case, so we are having true. And but here the same thing is not possible. Okay, because I mean this is a 4-letter and none of them is a 4-lettered one.
Is that because of that?
That is also one of the reason, and
Because it was not able to, I tried this AABA as a test case. It is like I think because of I tried if we make bottom as AA, we have AAA that can be made, and then next are AB. If we are taking adjacent, next is one place A and second place B. So then we also have ABA, so we can put A above it, and then next is BA. We have BAC. Then we can put C above it.
oh,
The only problem is we'll not be able to make above that because here it is like AC, and we don't
yeah,
have anything which
D.
is base as AC.
Okay, yeah, okay, that could
That
be.
can also be a reason, I
Yeah,
suppose.
definitely, yeah. And regarding the constraint, you have letters would be chosen from this. What is it? A definite set A to Z, G. Yeah. So how did you approach like this one? I mean, what would be the brute force like in this case?
I think brute force would be like just start with like BCD and then take two first, like I first two, and then search if this string is there with base, uh, like these two, is there any kind of a string is there? If it is, then we take that and then put
Proceed
over.
to the next level, a level up the bottom, right? One level above the
Yes.
bottom.
Yes, yes. So the only question is if we used that particular kind of a string, and and there is a case that occur again, can we use that again,
I
that particular string?
think, but if it is present 2 times, then only. I mean, they haven't mentioned anything like that, but
I think it should be possible, right?
yeah, it should be. Yeah, because that is present in allowed, right?
Yeah.
So
But
because I thought it is not mentioned that we need to use only one time. If it is, if
but
it,
will that case arise? Has um,
Yeah. Is there an example like that? Yeah, that's true.
yeah.
Mhm.
Yeah, but in such case, it's good to clarify.
Yeah, yeah,
Yeah.
with the interview, yeah.
Yeah.
So the thing which, yeah, the brute force would be like this only. Then take next two strings, move next two, and so maybe we can take any kind of a queue or something which would be like we just need to pop first. Like first of all, we put BCD. We need to pop B, and we don't pop, but we just only peak, and then make. level, second level of it, like put it that in a queue, G, we need to put
Okay.
G only because it can't be, we don't need to put BC, we only need to put G because that's a string, because we want to move to next level. So next, then since we popped B already, we didn't pop C over there, then we need to pop C and then just peek D, and then need to check if CD, if base CD kind of a string is there in our list, allowed list. Then if it is there, then we CDE is there. We need to add E in our queue. So so the one thing which is I am thinking, if our level is, if our, because this is a size of 3, think like a level order. If this size is complete, BCT initial BC level size is over, uh, we pop, will be we'll pop, we need to pop everything because that's the case, or just pop first two and then just no need to delete this, like take as some kind of a variable like previous or something, then add amendment, and that in that case our whole uh, first level queue would be deleted, then move to next level. I haven't solved it, I'm just thinking loud right now.
Mhm.
So initially you're putting entire BCD into queue, right?
Yes, yes.
Then so okay.
The only trick is we need to search.
In the allowed whether that is
Yeah,
there or not. Okay.
yes. And that could be the extra space. And we have a range of allowed strings till 200, so we need to search in 200.
200.
Feel free to go with other approaches. I don't have any.
So I mean you're replacing it. I mean you'll pop D then, right? Once you insert BCD inside the queue, you'll pop D.
Yes. Uh, so maybe we need to pop all these, like each time we need to pop uh, two things, B and C, like pop both of them. Just the last one which you pop, just take that in a one kind of a variable or something, because next time if when you pop again,
Okay.
that should be used. Previous one should be used. Like if we pop D, then the previous one, the last previous one, we need to add it and then use it. We can pop both of that from a queue. First time we pop B, C and take it one variable, and next time when we come to D, we pop D, but we take previous one C along with it, and then check if that kind of a string is possible or not. And we don't need to push B any kind of this in. We are only pushing G and E in our queue, because if next time we go with we are left with G and E, and GE is if we can see that any GE string is there, then we take that and we already pop these two, and we got A. The exit condition is like if in and put A in a queue, and if in the exit condition can be like if in the last uh, if in a queue only one string with only one this character is present, that means it is true, which is forming our pyramid. And if it is not, if we don't find any string and we have a queue we have in our queue two elements, this G and E, then and we are not able to form, we are not able to search this, then straight away return false. I'm thinking like that. Feel free to jump it.
But
Yeah, I think that is a good approach. Using a BFS way, only I would say a slight tweak in your approach would be using an extra space, and for that extra space means using some sort of a map for that allowed.
Yeah,
Yeah.
that can be possible. Like, we can create a map of these before doing any BFS. Like as you said, like the searching could be a costly operation,
Hmm.
and if we already know that B in BC, uh, the next one is G, top is G, then we'll be able to get some kind of a map can be created.
Yeah.
Anyone has tried other approaches or
in some, I saw that they were using backtracking. Like, I mean, if that is possible, check whether that is present in allowed or not. Like, I mean, brute force. Backtracking is what brute force only, right?
Not really, right?
I mean, like you are trying all the possibilities and checking if that particular word, three-lettered word, is present in your allowed. Go ahead. Otherwise, you retrace back from there. Go for the next.
But you will just look for it. If you don't find that, if you use a map, and you can immediately stop going that path if you don't
Yeah,
find
you
anything
return.
there, right? Yeah, you return from there. So it's like looking for if it's a visited node or not. So
Yeah.
should be an efficient way of doing it. Yeah. Yeah, I think the BFS also, as well as some way of a recursion also might help. You know,
Very clear. Yeah.
yeah, use some sort of an ordered map, and then use a recursive function. And in the recursive function, actually, you look for, as she said, for that base case, maybe like if you have that string, what you're looking for is just size of one, you say return true, or else keep on picking up two uh, letters from the input string always and look for if there is a match in the map. And if it is there, then you keep on forming another next
String.
a string for you say next regression call, and then keep on increasing that. So yeah, that also should be fine. Maybe sort of like a DFS approach, but not exactly like a DFS. Yeah.
So because C is a common child of G, and that makes it.
Uh, C is a common child. Yeah. So see what happens if you have this first three letters B, C, D.
Okay.
You obviously take the first two B and C for your computation to find the G. But when you are actually moving to the next level, sorry, the next what do you say, C and D, you are just discarding B. You are not discarding C, right? So you are taking
Yeah.
C and D, and then you look for whether you are going to get an E.
yes.
Yeah,
So it's like if we are started with first index, we need to move to the next index while we are passing.
right.
So will not be if though we use C, but in a first iteration, but will not be like discarding it. If we are passing, we should pass in index in an incremental way,
Right.
not a jumping way. Yes.
Yeah. So that should work. Yeah. So I have a very simple way, but I'm not sure whether it's very efficient way. But I use a recursive approach.
Okay. I share it.
Yeah, I can just share that. Yeah. Yeah, my screen visible, right?
Yes. Yes.
Yeah. So here actually, this is our entry function. I'm using a map, and in this map, actually, I'm doing the same thing what we discussed. Just take the first two letters and map that with the last one. So like if you have BC, so So BC map with G. So value will be G and the key will be BC. And in CD will be the value and CD will be the key and E will be the value. So this is a map that is created, and then you just run this helper function. And this is a string, the bottom string what we pass in here. And I'm also passing the map and then starting the index and then whatever. This would be my, a string to just store the next results. So as she also said, like the bottom size equal to 1, I just return true.
Why did you take map of string and vector of char, not string or string to char?
Yeah, this one, right?
Yes.
So it might happen, like you have multiple numbers of these things, you might have multiple strings. Yeah, therefore.
Actually, it is mentioned we'll always be having a triplet of length 3.
Right. But like if you have BCG, there can be something like BCD also. Yeah, you never know. Or
okay.
Yeah.
Okay.
So I'm just storing them here.
Mm-hmm.
Yeah, and then if you come here, if you see the bottom size, something is this one. This is another condition. If you see it is less than or equal to the last one, okay, then you just return this, or else you keep on going through this for loop, okay, and at any time if you find this is true, you'll have to return it true, right? So every time you keep on incrementing this index, and then you keep on adding this value next. Let's see. Right.
I didn't get this exit condition. If your index is last, start is equal to bottom size.
So this one?
Yes.
So if it is, so here actually it will return whatever the results you are getting from the previous one. Right. So when you are at the very end, okay, of the bottom string, bottom size -1.
Okay.
So you are just returning that value.
You're going to the next
with the empty string.
Yeah. So because you actually have to go for the next one, right?
Next one, yeah.
And here we are looping out on the basis of bottom first two string.
Yeah, so you always take these two letters here and you find what is that in the map.
Yeah.
Right, and then you get that character, and then you're trying to form the next level string, right?
Can you explain this line again? Start equals to bottom dot size -1. Like, why using that? That's a second line in the first function.
This one, right?
Yes.
Yeah. So start equals. So if you we can take an example, right? If start is 0, so if we start from here, okay. So if we take this BCD, okay. So you come from here, and then you have this bottom here. So here this won't be satisfied, right? This is not fun.
Yes.
So you come here. So for this start, now the start actually is value is 0 because we are starting. So just we actually leave it for now. Okay. Then we come here. The start is 0, and then your substring is 2. So you are having value BC. Okay. So when you look for the map in the BC, current value is G. Okay. So you go for the C and you just put G here in this helper function. Okay. So when you put G, okay, and you put G, and then you actually again go for this function over here. At that time, your next will be G.
C.
You should see.
It should C.
Okay. So let me write it over here. If we have this BCG. So the first will be BCD, right here. In this case, the water will be BCD.
Mm-hmm.
Okay. So, okay, so it comes from here. That is the BCD. And then you come here. So you get this BC. Okay. And then in this BC, you find G actually, correct? So
Yeah.
your next actually will be G, right?
Yes.
Yes.
So next will be G. So you are passing now, when you again come here, so what you are passing here? Your bottom hasn't changed. Okay, the bottom is BCD still, but your
Yeah.
start has changed. So start is now 1.
1.
Yeah.
One.
And the next is G,
Mhm.
right? So next is G. You see your bottom size, okay, is still not this one. And then your start is also is equal to, this was 3 minus, so it is 2. This is also not good there. So when you come here, okay, then you actually move from CD, right? So CD, the CD value is going to be E in this case, right? So when you come here, so what you have here now is this next will be GE.
GE.
Yeah.
Yes.
So next will be GE. So if you come here again, and this will be 2, right? So you have this GE and this is 2. So this is not satisfied, but this is satisfied in this case, correct?
Yeah.
So in this case, what you need to do is your GE, okay? So actually that is the next one. So you have to pass this GE over here,
Okay.
right? So because you're going to the next level, correct?
Mhm.
Yes.
So when you pass GE over here, you have to actually clear this, the real next actually what you're going to get here. So that is confusion over here. So your next actually becomes the bottom now. So now
Yes.
you come to as a G, and when you come to G, you do the same flow again, correct? So this is not going to be satisfied. This is not going to be satisfied, right? So then you will come and look for the map in the GE. So GE actually will be A in this case. So you follow the same thing again, right? So at the end, actually, when you come, if it is a single character, you will exit from here and then you will return to.
Okay.
Yeah, so this is using a recursive call like a DFS, but I'm not sure why actually it didn't give me a TLE though, because I'm still not using any memoization. I'm not sure whether I have to use it or not.
So
Maybe
you're getting TLE?
No, I'm not getting it. So I was just wondering
allowed
because
is only up to 200.
it's only 200, yeah. So the allowed range is not so much, and as well as the bottom is maximum to 2 to 8 only. And also the letters are limited. Yeah.
Yeah. Maybe because of that.
Yeah,
These
so
things.
maybe that actually helps.
The
But
delete was
actually,
also. Yeah.
yeah, but the way you started with BFS approach, I also thought of that. That is the best way to go with. But only thing is when you are doing a BFS approach, every time in a level, you know, when you are changing levels,
Mhm.
I would prefer to use 2 queues, right? One is the queue you start with this one, and when you're starting and working on this queue in one level, you
Mhm.
form another level, another queue for GE,
Mhm.
and then when you come out from this level, you exchange those 2 queues. So this becomes your primary queue again, right?
Yeah, like
Double
you are
ended
doing,
queue
like
won't
we,
work.
like how we are doing in this DFS. Like primary is 1, but if we end that size, we just need to replace the queue.
Right, right. So I thought because if you do it the normal queue, it was slightly cumbersome to do, but that is very intuitive actually, because we start with BFS and you can explain it very well, right? Because in this, it becomes slightly trickier, you know, when you actually did. I also didn't like this way to do it, you
The
know,
only
because
question
this,
now comes up in BFS is like, for example, as you mentioned that there can be chances of like BCD or BCG, correct?
yeah.
So we have, it means like BC have 2 children. It can either go to G or either go to D.
Mhm.
what BFS, but here what is doing, it's like it's just following like a DFS approach, going to path whatever it is coming, and if it is reached to the end, then it's okay. But in BFS, it will has to travel all the children,
Hmm.
uh,
Yeah, but
or
then
it
you
can
can,
be doable.
yeah. Yeah, but
I
you are saying that if it is like instead of GE, you get something like
D.
yeah, DE, and then you have consumed, if you even if you use a visited array there, so even
Mhm.
if you mark D as well as, then you'll have to mark for E also, right? So
Yeah.
you'll lose that E in that case. Yeah, that makes sense. But I think, this allowed range or whatever this input is, it will be very valid. They won't just give us like that, or else it will be very difficult to uh, in that case it won't be possible, like if you have BCG as well as BCD as an input. I don't think so. Even this case may work. You
This
got
can
my point.
work in DFS. It is work because as soon as we found in that, we just return it.
Let me try. Yeah,
Let's check
because
it.
yeah, yeah, it is working though, but
Then let's
even
start. I'll write it down, the BFS approach, and then let's see if it is.
because I was going through the discussions, I saw BFS approach, and it's slightly lengthy in many of the places.
But I'm not
Yeah,
using any BFS approach still now. Everybody
right.
done with this DFS only. Yeah.
Yeah. So,
Okay.
yeah.
Yeah.
Are you getting the combinations as such?
I'm sorry. Yeah, Uday.
I mean, sometimes, for the first letter or the second letter, there can be combinations, right? That is why you created that map to that vector, right?
Mm-hmm.
But in BFS, how do you get that combinations? I mean, for the first letter, for the particular letter, you can have multiple combinations, and for the second letter, you can have multiple combinations. How will you take care of that in BFS?
Okay. So you'll have to do it multiple ways there, right? Mm.
I didn't understand the question.
So he's saying like if you have BCG and BCD
Mhm.
in BFS, you'll have to take all of them together, right?
Yeah, that's the only reason which is.
So how
Yeah.
you do that?
Yeah, every letter can have combinations. So it will be, so if first letter is having n combinations and second letter is having m combinations, it will be like product of all those. So you need to create all of those, right?
But
Yeah.
your combination depends on the previous level, what it was, depending on that, right? It can't be like third letter can't come first, or first will become third.
No. But in the previous level, from the level plus one, on the top level,
Yeah.
the level above top can have, at the first letter and second letter, they can have multiple possibilities. So there are combinations coming, right? Here also in
Yeah.
the second example, for the first, for this level above the bottom, you have AA and both AA, AB, BA possible, right? For the uh, level above BCD, not,
BCD.
no,
No.
not BCD, AA, BA. In the second example,
Oh, second. Yeah, yeah.
yeah, you have AA, AB, BA. So how will didn't actually get how we will construct this combination kind of thing in BFS.
Actually, in that case, when you go to the second level, actually you'll have to refer to the map again when you are trying to form it. Maybe
To,
you'll have to form multiple such combinations.
yeah, how that actually, even for multiple combination, I'm thinking you would have to do some backtracking kind of approach itself. I'm thinking.
Hmm.
Yeah, that is hit and trial backtracking, right?
Like
Yeah.
you're not sure whether you're
I mean,
taking all the.
BFS or backtracking, you can call either, but you
Hmm.
need to do something of that recursion sort.
Hmm.
Mm.
But
But then it boils
that
down to
yeah,
those
that case should
things.
also happen on the recursion, right? If you have these
Right.
multiple combinations, it should have also. And I think if, because in the recursion, actually we're going through the map always, so that actually takes care of all the stuff.
Yeah, yeah. Here it is taken care, but in BFS, I didn't actually get how it is. I mean, it looks tough for me to get the combinations without recursion as such.
Yeah, actually, I was looking for one of those BFS approach, and that is the reason I said, they use two different queues, but they did a lot of processing in that also. So that might be one of the reasons. Yeah, I'm not sure which one was that.
So it
Yeah,
should
I'm
be.
sorry. I was always looking for the C++ ones. Yeah, so I'm not sure. Java using Q. I'm not sure what this was the one.
Bits they are using like more next level. They have taken this problem.
Yeah, this becomes very complex. Okay, yeah, this is not the bad. I'm sorry. There was something which I was going through, and then that's the reason I was bringing that point when she was discussing, right?
No. There is one more approach I see in the discuss where using DFS plus BFS. They are traversing with a BFS, but for the next level, they are doing DFS itself.
That DFS is backtracking, I think. I mean,
Yeah, DFS is
yeah.
backtrack.
I'm sorry. Yeah, maybe I missed
No,
that somewhere. Yeah, but yeah,
yeah,
it's not an easy problem to solve, I would say.
exactly.
Yeah, it looks very easy when you actually look at it. It looks very simple, but it's not so easy. Yeah.
It again falls under puzzle category, I think.
This is the one. Yeah,
Mm.
this is almost the same thing. What I'm also
I think
working on.
because we don't have much clarity about the reputation would be there or not, so that's the conditions we are not sure about it. If it is not, then it is possible. But if it is there, like combination of BC with other,
So
then it,
repetition is possible here. See, he said that AA and AB, this one.
yeah.
So it is possible, even this guy and this guy. So it becomes more tricky to handle this case. Yeah, I think so. Then because recursive, it handles on its own because it goes through each and every path, right? Therefore, it does on its own, so we don't have to worry about that, right? So only if it is BFS, then as you said, if you have these multiple combinations, then it is. I'm not sure whether it will be possible even to look for the map and come up with a valid, the next levels.
Can we do in iterative way, like
You
not
can use a stack in
using
that
BF?
case. You can just use a stack in that case. Yeah, maybe. Yeah, because even if you do a stack and the same, we'll land into the same problem what they were saying, if you have these multiple combinations, then how do we handle that case? Because, we think like, okay, AA, we take A and then we take B. That is the sequence we try to follow. But what happens if it's BA? In this case here, it is BA, right?
Mm-hmm.
So, so if these are only two, if there are many of them, so how do you handle that? That becomes more trickier, as well as it might be time consuming and it will be TLE. Yeah, if you do for each and every case, because you'll have to do many combinations, right, for each and everything, and many of them have multiples. Each and every letter has many multiple outputs. So I think if you leave it to DFS, the recursive way it takes on its own because the nature of the recursive calls, right? So they come back every time if it doesn't find, and then at least we can go to the next one. But should not that also work for a BFS? Don't know.
I know exactly.
Yeah.
It's like a bit hard to comment on that, right?
Yeah.
'Cause-
Yeah, but that's a good point, Uday.
yeah.
Yeah.
You can switch to next.
Yeah.
Okay. Yeah. So next is like optimal division. Set of list of positive integers are given, and adjacent integers will perform the float division. However, we can add any number of parentheses at any position to change the priority of operations. You should find out how to add the parentheses to get the max result and return the corresponding expression in string format. So this array of numbers are given, and you have to place the parentheses in such a way that we should get the maximum result out of it. That means new denominator should be minimum as possible. Like in this case, first they have divided 10 by 2, 5 and 5 divided by, 100 by 520, and 20 when you divide this. No, first it will go right. 10 by 2, 5, and 1000 by 5 is 200. Yeah, this way. And these are the other possible cases, but this is the case where max value will obtain. And there is only one optimal division for each test case, and element will lie in the range 2 to 1000. Yeah. So what would be the brute force here like?
So here, your denominator should be smaller.
Yeah, definitely. Then only, the result can be max.
Correct.
Yeah.
So if the denominator has to be smaller, in most of the case, you will have a numerator will always be greater, right? It has to be in an input also. So you cannot have an input of just two inputs, like one starting with 1000 and the second value will be like 100,000, that won't be a valid case, correct?
Yeah.
So we won't come into scenario. So always the first element will be the largest one. First element in the input.
So out of array, you will pick the greatest number as the numerator part, right?
Right. So
Now
if
you'll
that
place
is
the
then, yeah. So all the remaining if we put as a denominator, because when we put all of them in a denominator and whatever the way they are, dividing each other. So any time if you do it like this in this example one, whatever this example is, if you see 1000 divided by all of them, if you put to the denominator side, so at the end, how many number of divisions are there, ultimately it will turn out to be the least denominator, right? So that will take care by the basic of division. What you say, the division, the way the division works, correct? If it is 100 divided by 10 divided by 2, the way he is dividing.
So
Right?
each time you are repeating the same pattern only, like, even in the denominator part, you will try to first find the numerator with the greatest number and go for the denominator with the smallest. Again, this like 100 by 10 is a numerator for 2, right?
So is it 100 by 2?
100 by 10 is a numerator for 2. Yeah. So
100 by 10 divided by 2 will be like
5.
10 divided by 2 is like 5, and then 1000 divided by 5 is 200.
Right. Yeah.
It will be giving the same result in over.
Yeah. So
if we if we do like 10 divided by 2, which is 5, then 100 divided by 5 is 20. But 1000 divided by 20 would be
50.
That is reduction. So the answer should be like we need to get a minimum.
So always try to take greatest number as the top numerator and smallest number as the extreme denominator.
So the solution, like what should be the solution is like if we able to find the minimum division, like minimum 50 or at 200.
The solution, yeah, the answer what they want is the output should be high, big,
Max one, yeah.
This is
maximum.
going
Okay.
like a recursion, right? You always find the
Exactly.
highest in the numerator.
Yeah.
I thought it's the recursion way, but if you look at the implementation, it's very different. So if you do it recursively, what would you like to consider here if it's going to be
So
recursive?
first find the highest number and use in the numerator, and next in the remaining numbers again find the highest number, use in the divisor, right? In the divisor there are again divided into numerator and divisor.
So yeah. So the best case is to sort in a decreasing way.
Yeah.
Yeah, but no, if you see in this case, the way you said, like if you have in the bracket what you have 100 divided by 10 divided by 2, if you pass that as a recursive parameter, right? That is what you are trying to say. You're going to take 100 as a numerator and then you will take 10 by 2 as a denominator, right? In that case. So that approach,
And
if you
you start using parentheses, right? When you find 100 by 10, you put the parenthesis and then divide that parenthesis, that result by 2. And then if you have one more number, then put the parenthesis again on the divisor expression and then divide by the least number.
I think there can be chances of multiple paths. I would say we need to go in that case.
One question about the input. Do we need to consume the total input or partial can be possible?
No, total you have to
Total
consider.
input. Yeah. And I think the input array's length is like 1 to 10.
If it was partial, then 1000 by 2 would have been 500 would have been the answer, right?
No. They said actually you can use only adjacent numbers. That's why I was asking. You can't use 1002 because they are not adjacent.
Oh, it's mentioned.
Yeah, we need to use adjacent as a way.
Oh. Yeah,
So
that's a good question.
when you are actually using adjacent, it means you have to actually evaluate this function, right? So you have to evaluate that, and then you make those adjustments. So when you have some numbers remaining, like you have 100, 10, and 2, you actually first evaluate 10, 2, then use that with 100, and then use that with 100, the one which you have, that will be the adjacent. And then when you have a value of 100, 10, 2, that you use with 1000. So that is the way I think he means by the adjacent.
I was actually thinking it was a kind of a DP problem where, if you use that particular number I, the divisor should be minimum out of that I plus 1 to the end. So you can either pick that I plus 1 character as the divisor or I plus 1 to any of them. So it will become a sub problem of I plus 1 to n minus 1. You can either pick 1 or 2 or the complete string. If there is no requirement of consuming the whole string.
So how are you taking care of adjacent in that case, DP1?
So it will interact with only I plus 1 itself, right? So you need to get what is the minimum divisor, minimum denominator that is you are getting from I plus 1 to n minus 1. So that should be contiguous itself. Either I plus 1 or I plus 1, I plus 2 or I plus 1, I plus 2, I plus 3, something like that.
Oh, pairwise, yeah.
I was also looking for the same thing, like what he said. Like if you're at 1000, like 0th index, you can take 1000, 10 and 2, or you can take like you can do 1000 here and you can do 100 by 10. Like you will take overall 10, or you can take 1000 by 100 as 1 and then 10 and then 2, like this. Are you getting like what I'm trying to say?
Can you come again once?
Like what I said is that if there is 1000, 100, 10 and 2, then what I can do is that I can do 1000 by 100. Okay.
Okay.
Then one case arise that the array will become 10, 10, and 2, right?
Okay. Yeah. Oh, first you computed 1000, 100, yeah, 10, 10, 2.
Okay. And the other case can be like uh, I will take 1000 as it is. Okay.
Okay. Okay.
And I will do 100 by 10. So it will be 10 and 2. Then my array would be 1000, 10, and 2.
So adjust. Yeah. Okay.
So I'm trying to do in this way.
Yeah, it's trying to evaluate the adjacent ones and then try to find which will give the maximum results, right?
Yes.
Yeah. So
I
yeah,
think yeah.
But if there are
So
n numbers, then he will make such. Okay.
I
N.
think at each index you have two options. One option is you take the current element and the next one. You do the division and then you recurse. The other option is you skip over the current element.
You can't skip.
yeah. As per Uday, he says that you have to use always the adjacent.
Yeah.
But then what I say, if you have to, yeah. So Hani is saying like you can do the knapsack problem, right? So, but I would say, as per his logic, it won't work because you can't skip anything.
Yeah. That's the problem.
But the adjacent, what I think he means is you'll have to evaluate, right? If you have 1000, 100, 10, and 2, first you evaluate the last two elements, okay? So whatever the results you get from that, okay, so now your input array will be reduced to only 3, like 1000, 100, and whatever the value is, if you consider this as an x1, okay? So in that case, then again, okay, let me just write it here. Okay, so here, if we say this 1000, then we have 100, and then we actually evaluate this 102 if we say this is the next one. So now again, you go in this recursive way, you say 1000, and then you evaluate these two, and then you get something like an x2 value. And then now you have these two adjacents, and then actually you try to evaluate this value and get it, right? So then if you look at the paths, what they are following, they actually go different routes also, right? Instead of just following this one, you can also have this first, and then you actually take this x1 and then do with x1 by 2, something like that. You have x1 here and then you have 2 here, like 1000 x1 and 2. This will be another route going through if you are using a DFS, and then you form this as an x3, something like that, and then you evaluate that x1000 to x3 and keep a max so far count always, and then you return it, right? So that might be one way of doing it, but this is an adjacence again, right? So he's not actually saying strictly to just be with the input adjacence, but when you are trying to evaluate and you have intermediate steps, your input actually size keeps on decreasing, right? So that might be one way of actually considering it.
If you go from back, like 10 divided by 2 and then so on, that will give you 50 only, right?
No, so you will have to do it. You will have to evaluate each and every path, right? So this will be a recursive way, right? Going from 1000 to 100 to 10 to 2. You go to the last value, then you evaluate that. Then if you want, you can skip that value, just do 110 and then consider the next value, something like that. So there the skipping will be okay.
Okay. Okay. Yeah. Yeah.
So
you'll
this is the way
evaluate all
I would think,
possible paths.
yeah.
Yeah. And I think they have also.
I'm sorry, yeah, you'll have to erase this or undo it. Okay. Can't undo this?
Yeah. Oh, yeah, I can. I'll remove it.
Please, sure. So you will have to use all the values, right? So without that, why they will give you input, so much of a big input, right? So if you have, if it's just look for the adjacent values, if you look for, you can just iterate the string of O of n times and just find out the value. That will be very easy to do.
But this is a sorted one, so it looks like, I mean,
Worst case, you will do a sorting in case if it's not sorted.
But if you sort it, the orientation won't be changed.
Yeah, so that will be another problem. So no one
Yeah,
wants
so
you
you,
to change the order also,
yeah, so you can't do the sorting.
because that's not said over there, right? It's sorted or not sorted.
No, it's no normal. It will be. I mean, it could be anything, right? If we add
Maybe,
any.
yeah.
Yeah.
You can't actually sort it, but if you are actually sorting it, you would actually get a new solution where 1000 by 2 by 10 by 100.
1000
Sorts
by
like
2 by.
I mean, you decrease the denominator even down. I mean, you decrease the denominator to points, 0.2, 0.002, something like that.
Mhm.
I mean, you can actually rearrange that 100, 10 to
yeah,
2, 10, 100, something like that, right?
2 by 10.2 and again divided by 100. So
Yeah,
0.002. No, but when you divide that, 1000 will go up. It will. Yeah, it will make more value. Correct.
yeah,
Mm. But we can't do that, right?
yeah,
We
yeah.
can't sort it.
Yeah. So do you have the recursive approach? Uday?
Cursive, would I?
No, 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 I think I thought that you don't need to consume every
Element.
yeah, but if you have to consume, it will be like uh, that first element by rest of the element itself, right?
Yeah.
So then if you are not want to consume, so why they will specify? If you look at the problem statement, it's clearly specifies, however, in the line what it says, however, you can add any number of parentheses. So the way why is trying to give more emphasis on the parentheses, so if you actually add parentheses, so you are actually making that whole number, adjacent to another number. So that is what he's trying to say. So you'll have to evaluate that when you add any parenthesis. He wants to evaluate that also.
No, no, no. I think it's redundant only because if you are dividing a number again by a positive number, it is going to decrease itself, right?
Absolutely, yeah.
Yeah. So since you need to consume every number, I mean, I'm not sure. I'm guessing it should be thousand. I mean, it should be always 0 by 1 by 2 by n minus 1 itself. I'm thinking so. Because these are all positive numbers itself and you are dividing it again and again, so denominator, yeah, as the sequence, I mean, if you are increasing the sequence, the denominator is even going to decrease, so you are increasing the resultant value as well.
I didn't get the last statement. What do you mean by?
So let's I mean, so now, I mean, whether we need to consume the whole string or not, I didn't get that.
Well, it has to. That is what I would think of, because or else they would have specified something like that, right?
Yeah.
Then,
I mean,
then I'm thinking it will be first one itself, right? I mean, the 0 by 1 by itself, right? Because if you see, if you are consuming the whole string, 0 has to be the numerator itself.
yeah, it can't be denominator. Yeah.
Yeah, that is true.
Yeah, and how will you use the rest of the things?
So
You-
so you will use the rest of the things to make it minimum.
No, but it will always be 0 by anything, right?
Yeah, it will be 0 by anything, but the rest of the things will be make it minimum, whatever the way you want to do.
no,
But
no,
we are sure about the result. Whatever you do, result will always be 0. So why to then unnecessary make any.
No, why
Um,
don't we just brute force is why don't we just pass through the numbers and add the parenthesis and divisor, right? That will be simple brute force.
No,
Yeah,
no,
I
actually,
think
I'm thinking it is a straightforward thing itself because you
Yeah,
need to consume all the n numbers and 0 is the numerator itself. So
right.
I just
if
did
you
that
have to
brute
use n
force
minus
now.
number, you need to keep that as divisors itself, right?
Mm.
Numerator, yeah.
I just did that same way using brute force now, and it is okay.
Yeah,
Okay,
so
sure.
that works, but actually the logic, what Uday is saying makes sense, right? So
Uh,
if they are giving an input like that, so how do we actually use those? Why they have given it? And when they say about adjacent integers,
no, they said length of input array will be from
Uh,
1 to 10.
here element will be between 2 to 1000, right? And we
Yeah,
are having
element will be
float division, so we can't have 0, I guess.
exactly, yeah.
zero in the sense they are referring to the zeroth index of that array, right? So
No, is it or element they are is referring?
so it has to be element, the zeroth element. That is what it's saying. That will always be a numerator. If that is not a numerator, then thing is not going to be
And also you have to use adjacent integers only, right? So I think it is straightforward rather than what we are
right, right,
complexly
right.
thinking here.
It is straightforward,
Yeah.
but what is the actually thing? When so if you say it's a straightforward, is it so because it's a medium problem too?
Okay, okay. You're thinking that way.
Yeah. So he's
Okay,
trying to bring a point there, So
okay.
if they're saying adjacents, what actually it means by that? But yeah, the implementation is just the way they have said on the first one, right? You just take one numerator and then put all of them in a denominator, then you
Yeah,
return and
denominator.
yeah,
Yeah,
then it should
yeah.
work. But it really doesn't make sense,
Can you check with another input? There's like a sorted, right? 1000, 110 to.
Hmm.
We are actually not, I mean, if we have to,
I've checked without sorting, and it is same as it takes others as a divisor, and just put the parenthesis and the division separator.
It
yeah,
still works, right?
Yeah, it doesn't do any sorting or anything. If you give 1050 to 10, so it just arrange in sequence and put the parenthesis.
It just like
Yes.
converting it into string form and then returning it, right?
Yeah. It's just converting. Yeah, that's true.
Yeah.
Yeah.
I mean, actually, that might be true actually because if you consider that 0 as a numerator and the rest of the thing as denominator, I mean, that is what we need to make the expression as parenthesis and this all, right? So if you are keeping that, we need to make another a lesser denominator out of that n minus 1 substring. If you are not dividing by the previous number, you are actually increasing that number, right? So if you see that that explanation, you are taking, the 100,000, 110 to should be part of the denominator, and we need to get the minimum value. So 100 should be divisible. 100 should get divided by its successor. Otherwise, the denominators we are increasing. Denominator we are decreasing, and the value, the n minus 1 substring denominator is increasing, right?
Yeah.
So it makes sense to directly put it 0 by 1 by 2 itself.
So in the first example, if the input, the last two were swapped, so we still use the same values, right?
Yeah,
But in
because
that actually you are not getting the lowest value in that, correct?
yeah,
So we
we
could
need
get
to
lowest
decrease that
value by
n minus
actually arranging the parentheses there too, right? So if it is 100, 2 and 10, right? If you use this the same way what they're doing, but we could rearrange the parentheses and make it slightly lesser than what we could get by this way.
And also looking at the, there is one more observation you can make. Looking at the dislikes versus the likes, it should have been, it should be put in easy. That's why there are
I
more
just have
dislikes.
one issue.
Yeah.
If the input is like 100,000, 5 and 2, then of course, if we take 100, like suppose 1000 by 5, then it will be 200. Then we will do 100 by 200. Then definitely, the numerator
Zero.
will be like in the 0th index. That's for sure.
I think the problem examples explanation gave us another thought, but it's just like a simple, we need to add brackets and division, like that thing.
Right.
Otherwise, this explanation made us more thinking.
Yeah.
Diverting from
No, but actually, if you look at it, you can't come out with this simple solution in an interview also, right? If you just return it like this.
Yes, exactly. It is written like this. That's why we are giving our we are digging our thoughts a lot.
Yeah.
What would be
Yeah.
the
And also
answer?
it is rated medium, right? So another,
It's just like we need to make it a string with the brackets and division sign. Yeah. I just like
but it's very, very tricky when it comes to interview. It will be very hard to explain it to them.
Yeah.
And the problem is if this kind of a question come up, like some like online test comes up and nobody's there to answer, like interview is not there to explain what they are expecting. So that would give us like a thought, like if we are following the good direction or a bad direction.
This will come only online test only.
Online
I
test.
think so interviewer will ask because.
Yeah.
We are assuming that too again, right?
Yeah, only thing is you can do is you can verify your test cases, what you can think of, if it's possible. Otherwise, yeah, you are in soup.
Yeah. But I like the way what Uday said, you do a DFS approach in that case. You keep on recursing and then keep on finding what remove the numerator part. Just play with the denominator and try to find the minimum value out of that.
Yeah.
So that might be a slightly better way of actually, and you also will be satisfied, right, doing that.
I think this can actually go for toss if we have negatives and zeros. I mean, here it is always positives. That's why, since we need to decrease the denominator, we are actually dividing it by successor itself. But if there are negatives and zeros as well, that won't be straightforward, I'm thinking. You need to have proper parentheses and if there are multiple negatives, if there are even number of negatives, you try to make the denominator as positive kind of thing. You try to do some sort of that kind.
If you have even number of negatives, they will cancel out, right? Anyway, but only the problem will be with the odd ones.
Yeah, odd ones.
Yeah, but in that case, the problem won't be even this won't be a valid. They won't have valid test cases also, right? It will be very difficult for them even to put that.
What happens if the number if some of the numbers are zero?
Yeah.
Zero.
Yeah, if it is zero and negative, then the whole scenario changes. I don't think so. The problem will be so easy to solve also. So if it is zero anywhere, if you have to divide, then it is a problem. You have to have zero only on the numerator side, right? Or else it's not of use at all. It will be infinite.
No. I was actually thinking you need to keep, so for the denominator to become decreasing, it should actually come in the numerator part somehow, by parenthesising. I was actually thinking in that way. But if it is not immediate, somehow it will end up in infinity or something.
Yeah. Yep. I guess so.
Different aspects.
So let's move on.
No. Let's say 1,000, 100, 0, 2.
1000, 100, 0, 2.
Yeah.
In this case,
Yeah, in this case itself, 1000, 100, 0, 2.
So 0 you can never keep in denominator and not in numerator also, because that will always give 0.
0, 2. Let us see what he's saying, whether it works or not. But here actually, yeah, it's a string, so it might be fine. Yeah, it is a string, right? You're just returning string.
Yeah.
Yeah, so it is accepting. Yeah. So this is something weird. But I think we are saying he's saying the list of positive integer, it means no zeros, right?
Yeah. So if
So
you have 0 divided by 2, the denominator 100 by 0 will become uh, uh, even big denominator. But if
yeah.
you have 100 by 0 slash 2, uh, you are making the denominator as even less, something like that.
But that itself is not allowed. 100 by 0 is undefined, right?
Yeah.
You are saying infinity, but I'm here forcibly going ahead, right?
Yeah, I mean, if zeros are considered part of value.
Yeah.
Yeah.
Yeah. So now for this it's not though, but in that case it will be different. He won't even allow us to do a string because we'll have to do some computation, right?
Yeah.
Yeah, but that will be a totally different scenario to look for. Okay. Yeah.
Yeah. Yeah. So Pradeep wants to share code, right? Pradeep is there.
Yeah, I can share. I can share.
Okay. Okay, sure.
Can you see?
Yeah. Can you increase your font size? You went back.
Yeah, just 1 second.
Sure.
Yeah, can you see?
Yes.
Okay. Yeah. I just wrote it now. So I just add string. I take the first string as a numerator. So if it is greater than 2, I start, do the string concatenation, starting from the divisor and then the bracket, open bracket, and then the close bracket. I'll go through each element and then close this. If it is just there are only 2 elements, then I just put the divisor and then the symbol and the divisor. If there is nothing, there's just 1 element, just return the 1 element as a string.
Okay. But you don't need that last else. Yeah. Okay.
Yeah, no need. I just did it for
Completion.
completion.
Yeah. Okay.
Yeah.
Yep. Makes sense.
Okay.
Yeah. No problem. Thank you.
Yeah.
Yeah.
Awesome. So our next is like cut off trees for the golf event. We are supposed to cut off the trees in a forest, and the forest would be represented by 2D map. 2D, yeah. 0 will represent obstacle, 1 represents ground, and if it is bigger than 1, we can walk through it, and that number will represent the tree's height. And we are supposed to walk in all the 4 directions: top, left, bottom, and right, when standing at a point. We are supposed to cut off all the trees in the forest in the order of the tree's height, and always cut off the tree with the lowest height first and follow on. We'll start from 0 0, and we have to output the minimum steps needed to walk to cut off all the trees. If you cannot cut off the trees, just return -1. And no trees will have the same height, and at least 1 tree needs to be cut off. So here, if I stand at 1, then 2, 3, 2, 2 will be deleted, 3, 4, 5, 6, 7. So these 6 trees will be chopped off. And here we can't, because if you are at 1, 2 and 3 you can cut, but again 0 comes, which is an obstacle. So none, I mean, it's not possible. So -1 you return here. And coming to this, if you are at 2, so 3, 4, 5, and then these 3, 6. You started from point 0, 0, and you cannot cut off the tree in 0, 0 directly without walking.
So the one thing, if I need to ask is like, if we don't have like obstacle 0, 0, and somehow we found the shortest path, like we directly jump instead of these coordinates of 1, 1 at row 1 and column 1. If we have some other, like for example, let's say 1.
Okay.
Then if we go to 2 and then we'll go to 3, and then we can directly go down because 1 is the smallest. And but the only question is we need to chop all the trees to return the 8, to reach to 8. Like,
Right, but here it is the maximum number of elements. It's not the shortest one, right?
it's written that you need to minimum steps you'll take to chop off all the trees, I think. Yeah, to cut all the trees, the minimum steps you need to walk. And it's mentioned that you should cut the trees in the forest in a height ways.
Yeah,
Like
the lowest first.
the lowest first.
But he says that you have to cut all the trees, right? Or whatever maximum possible. But in a shorter route, maybe in the minimum steps. Is it specified exactly the minimum steps?
Yes.
It's written. Yeah.
Non-negative.
So maybe if it's like we able to cut all the trees in different number of steps, we need to return the minimum one.
Yeah, so yeah, if you are able to cut all the trees in the least way, so first of all, if for me it comes out to be like if you have to cut all the trees, so it is like it will always be a bigger number, right? But you try to do it more efficient. That is what he's trying to say. If you have 2 paths in that, you try to pick up one path, because if there is one in middle, just avoid them, something like that. So, but still you have to cut all the trees. And if you are not able to cut all the trees, then you return -1.
-1, yes.
So yeah, so that's the trick. Like if we have 1, 1 in middle as well, but we can traverse that. But the thing is, all the trees are not cut yet.
Right. So therefore, they're trying to confuse us by saying minimum steps.
Yes.
When it says minimum step is like what you say, like the BFS way.
Yeah.
Yeah, but it's not that. But we still have to cut all of them.
Yeah.
Maybe the thing is, if while traversing, like if we have 4 directions, just make it like traverse that which has a distance of which the next element is the smallest one.
Yeah, that is correct. That we have to do it that way. We have to go for the smallest one. We have to always go in the increasing amount.
Increasing amount.
Yeah.
Correct.
But also when he says it, you always have to start at 0 position. So if you have some value at 0 other than 1, so then we should consider that as also a part of our input, right? Output.
0 other than 1 means?
Yeah. So in example 2, if we take example of 1, you have 0 position where it wants to start. Like if it is 1, 2, 3, 4, 5, 6, 7, instead of 1, if it was 2 here.
Yeah, that can be possible. We every time we need to start from 0, 0. So 2, then we need to chop 2 and then move ahead.
Yeah. So for me, the confusion was right. You cannot walk through that SL because there is a tree there, right? So you have to cut it, and then only you can walk. So for you to position yourself at the first cell, you should be on the grass. That is, you should be at least on level 1.
Actually, they mentioned here somewhere, think I have read it, that though it's a tree, you can stand it there. Like,
Really?
yeah,
Okay.
like,
So in
It
that
is.
case, you should not count that cell. Okay. Because they're not counting it anywhere. That makes sense then. It's a very lengthy explanation also of the problem statement.
like it's mentioned also when standing in a point where is a tree, you can decide whether or not to cut off the tree.
Mhm.
So this is a line over here, like in one step you can walk in 4 directions, and also when standing in a point, which is a tree. For example, if we started at 2,
Mhm.
and 2 is a tree, and we can decide it whether we want to cut off that tree or not. Like for example, if we are on some higher height, let's say if next 2's next is 7, and we can move to 7, but we will not chop it off until unless we find some other shortest one. We'll cut off that and then return back to that.
Mm.
I think that's the line which they are mentioning.
Yeah, makes sense.
So from every node, you will try to find the shortest path, right?
No, you start with the 0th one, 0, 0 position. Correct. And then you start traversing it in all the 4 directions.
Yeah.
So wherever there are obstacles, you just don't go there. And so whenever you are going to the next one, you see that it is bigger than the current one, right? So you can count it. And then you follow the path in such a way that you have the maximum value when you're going down that.
I was thinking of doing with the BF, but the only trick is like if like we put 4 directions children. Let's say start at 1, we put like it's children in that, and then the next we just need to we will be traveling that path which has a shortest shortest one, shortest tree as next, and but there can be chance that the tree which we moved, and it's for example if we move to 1 to 2, maybe um, let's say 2 is not there, it's some kind of a 8, 1 to 8, because the only path we can travel from 0 0 is to going right, and it's only children is 8, and we can't cut 8, and because its next children is 3.
I think
Mhm.
first we can scan the 2D array and try to find the order in which we need to chop it out. Then we can along with the order we need to have the coordinates like row and column. Then we do a BFS from lowest to highest.
Yeah, sort that elements and sort the tree's height, and you start 0 0 to lowest and lowest to lowest plus 1, something like that.
Sorting will again change the order.
I mean,
No,
you need to follow that order, right? You can. I mean, you need to cut the lowest tree first, then lowest plus 1 height, something like that.
we can have a ordered map with the key as the value in the tree height and value as the coordinates. Then we can first from 0 0 we need to find the first element in the ordered map coordinate, do a BFS to that and try to do a BFS to next and so on like that.
Yeah, that still would be
Okay.
I mean, it's similar to sorting itself. Yeah.
Yeah, but so each and every level you go, you have to do a BFS, right?
Yeah. Anyway, we need to find the shortest path. We need to do that travel the whole path again and again. Like that's the answer we need to find, right? Like we need to chop the lowest one, even if we have other tree nearby, we need to chop the lowest one, so we need to go somewhere else. So we need to do a BFS from one to other. That would be minimum.
Okay.
Yeah.
So you take one element, and then you do a BFS with that, and then keep on going in that direction. And the next one again, you do it that way, right? Okay.
Yeah.
There are too much of computations in it.
I think instead of going sorting way, we can go with the priority queue.
Right, that is also one way. But yeah, either of it, priority queue or sorting, we still are actually adding additional computations. But that computation, I would say, is very minimal compared to the way you are doing traversing, because if you are doing traversing for each and every element, right? You are like in a BFS, you are starting a BFS for the 0th index, okay, then you go for the first index, okay, you start for that, and again second, third, fourth, you keep on repeating, correct? So anyway, that will be huge. So even if we have a sorting, or if we have a priority queue, it's not going to, yeah, it will be okay, because the computation of doing BFS for each and every element is very huge. That's not it's negligible, I would say, for the sorting. Also the priority queue will be slightly efficient for sure.
In priority queue index with the height you will put, right? Or simply height of the tree.
We can sort it on the basis of height, and we can put the index.
Yeah, height should be the better way of doing it. Like it will be the min heap in that case, correct? Yeah. But were you able to get through this without TLE? Because I think they have changed the test cases somewhere. I don't know. Has anyone done it? Because just the normal BFS and all those approaches, even if you do BFS or other than BFS, any traversing, you still hit on a TLE, correct? Or no?
Yeah, you let TLE.
So we can do one thing here. If we do, if we calculate distance from 0 point for all the trees, then we can easily find distance between any two trees.
I think, all.
So the formula is there any share? Yeah. So suppose
Euclidean distance, right? Oh, you want to share a screen?
no, I don't have code right now. So suppose DI, suppose this is your distance array, and the array represents a distance from 0, 0 location. And if you want to find distance between two nodes I and j, that means the distance would be distance of j plus distance of I minus this will be the formula.
But what about the obstacles?
Yeah, exactly. So whenever you will, first time when you will do DFS or when you calculate distances, you have to ensure all the trees should be reachable. And if there's some tree which is not reachable, that means it's not possible to cut all the trees. So that would be your -1 situation.
Read the matrix as a graph and do something like that. I mean, all pair shortest path. I mean,
yeah, we can think of that also, because the problem actually it's a like modified problem. Problem is we want to calculate distance between any two of the nodes in a graph.
Dicastra you're trying to use, right?
No, no, not
No,
Dicastra.
that's not.
Something
All
like
source
Bellman
should.
Ford. Yeah, Floyd Marshall, I mean.
Yeah, Floyd Varshall.
Or Dicastra is single source shortest path. Yeah.
Floyd Varshall, you find each and every distance, right, for each and every vertexes.
Yeah. But how will you take care of obstacles there?
You just ignore them.
You won't add it them.
I think
Next vertices.
All right, yeah, that should make sense. And then you won't hit a TLE also in that case, correct? But
Yeah.
Floyd Varshall will
Not
still.
sure. And this is just an assumption.
Yeah.
Yeah.
Because I found in one of the discussions they are using Shashank's favorite algorithm, A star.
Yeah, A star there.
Yeah, yeah.
That's also like shortest path only calculating. They are taking all, I mean, in Dicastra, like we do know, if we take this node, so what will be the shortest path? If we go to the other way, what will be the shortest path?
A star is also like DFS only, right? Just that we are prioritizing towards a certain path.
Yeah, kind of. Not exactly. It's a DFS, but like it uses mechanism of Dicastra algorithm only.
Yeah, basically you have a distance between, I mean, where you want to end up at and where you are at.
Yeah.
Yeah. Do you
That
want
is the
to?
most optimized way that they have done.
Yeah. Do you want to share any code and just walk through any of you?
You can look in discussion if any of you has done, then Dilip has done. I mean, he was sharing some BFS.
no. I that's it. Thought actually. I didn't thought.
But does a BFS actually not timeout? Just a question.
I didn't try it actually. Like, I just
No, that's fine. But anyone other than you.
But I think you shouldn't get the timeout, right? Like, because we are giving priority to chop the lowest one, so we need to travel that path. But extra sorting may give really, but without that sorting, we need to try anyway. We need to travel the matrix in those paths.
Yeah, the constraints are small, right? It's only 50 by 50 matrix.
Okay.
And I think we should make.
So it's like 2500. Yeah, it should be fine.
You can go through discussion then. So anyone share like? Let's see here in the discussion.
Mine is TLE for BFS and the priority also. Priority queue approach, yeah.
I think they are
I
sharing.
think the first one is, yeah.
So they use something like that. What approach? The Hadlock approach.
Priority queue on the top of that BFS.
Mhm.
I think priority queue just to for
Minimum
all the
count.
elements to sort it out, like because we just need the top element. That's where priority queue would be the best.
So they are pushing the index along with the height. I mean,
Yeah.
and sorted by height. Then each time they are. It's too much, right? Order of m square into n square.
Yeah.
And
Because
how it
you have to go to each and every row and column, correct?
Yeah.
So you're doing a BFS, right? And therefore, I think Pankaj also and Uday was saying, you could use some other algorithm, Ford version. Yeah.
And
That
Pankaj
might.
was like doing some distance.
Yeah, that actually first calculates the shortest path with respect to 0 for each and every one. Okay, and then actually you find out.
You'll be putting the distance in the priority queue or directly from calculating the distance itself. Like how do you get the minimum distance?
I shared formula in the chat, so it's there.
Yeah, from that you will get the distance, right?
Yeah.
But
So
he's
we
saying that how
can,
do you find the
yeah,
minimum?
queue. Yeah, sorted queue.
Yeah, that yeah. What was that LCA least common LCA you were using? 2
Yeah,
times of
least
L.
common ancestor.
Okay.
So you are saying that you take all these elements and form a queue or a sorted list, right, Pankaj?
Yeah. No, for first is we can have a graph and pre-compute this array D and LCA. And then we can just have all the tree nodes in the graph or matrix. And of course, we will put them in a queue, sorted queue, and just take out one by one in increasing order of height. And for just let's start with first one height, and then so then we can see what's the distance from 0, 0 to this height one tree. Then next height is say 4. Then we can just find the distance between these two through this formula and just keep on adding them.
Looks interesting.
So here to recalculate this D array, it's just a one DFS call on a graph. And while doing this, we can simultaneously have our LCA array also. So both can be done in a single DFS call. And yeah.
Okay.
Yeah, I think we have to.
Okay, so this is a BFS approach what you're sharing, right, Susan?
Yeah.
So it is the normal BFS approach, only just using the priority queue.
He first used the priority queue to sort the tree with the height, with their heights. This area.
Right.
And
then you are just extracting each and every element from that priority queue, and then trying to find the minimum step
using BFS.
Yeah.
Yeah.
Yep, makes sense. But I'm not sure whether this will pass. It might give a
But they have
KD.
posted it. No, they have 132 of boards also. So
When was that posted? Around 2018, right? So I think they have changed the test cases now.
oh, might be okay.
So
Shishan, can you try it now? Can you try to put it and run?
Shall I run this code?
Yeah. What can you run?
Yeah. So this area I have to copy, right?
I think you can copy the whole solution because it has other things also in it.
Okay. Yeah, it's accepting.
Wow.
Okay, that's good. But C++, the BFS priority actually is not accepting. Yeah, maybe some more optimization will be done. Yeah. Okay, good. So at least we have one way of doing it, right? Okay. So use a priority queue with the height-based priority.
Yep. So if BFS is used, DFS also we can try, right?
Yeah, yeah. What should work.
DFS won't give us the shortest path, right?
BFS gives the shortest path.
Yeah, I mean DFS won't give. We can only use BFS.
No, you DFS also you can get shortest path.
No, he's saying that it might take more time, right? Yeah, that also makes sense.
Oh, okay. Yeah. That BFS would be.
Yeah. Okay, so at least we have something. Yeah, no problem.
At least one way we have, yeah.
Right.
Okay then.
Okay.